Hi guys, good morning. Doing a quick check before we begin. Can you see everything? Can you hear me? And by the way, I don't know why it said it started at 9. I scheduled it for 11 clearly, but I know on other ones, like for the BC, I think it's because it's mountain time or something on there. I never checked that before, but I think it's going based off mountain time. So I'll be sure to correct that for future videos. So sorry about that. Or maybe it's California time. I don't know. I guess it would have to be if it said 9 and it's 11. Okay, so I can hear. Can you see to Avatar Network? Lubes. Oh, hi again, Graham. Oh, okay, California time. So, yeah, I'll fix that. I never thought to click that. I figured they know everything else about us, so it should know what time it is where I am. Anyway, okay, so we're going to get started. I see that before we get started, I want to clarify something. So I received an email from a parent saying, hey, can you help my child with this problem? We emailed you on WebAssign, and I went into WebAssign because I don't check the WebAssign emails, and there were 52 questions. So remember, the rules are this, and they're posted. I cannot reiterate it enough. You need to ask me a question via Edsby or Remind. I was just in Edsby before I clicked the live button, and Edsby's acting up again. Nothing new. So if you try to send me a message through Edsby, and Edsby's slow or giving you trouble, just send a quick message to Remind. I don't need a picture of your assignment. I can go right under your name and see exactly what you typed in WebAssign. So all I need is the problem number and your name, and I'll be able to go in. And what I decided to do is make quick little videos addressing certain problems. And the reason why is because you all have different problems in WebAssign. Okay, so there were a lot of questions that I found where many of you are using the distance formula incorrectly. All right, so let me just start out by asking you this, because on my computer I have your class up. Oh, I have both classes up. And does anybody have a particular question about either inputting information in WebAssign, or perhaps you had trouble with a problem in WebAssign that you want to go over? Homework questions. Asking for homework questions. Number 12. Okay, so let me go in. Austin, you're in block 1. So even though Austin's number 12 might be different than your number 12, the idea is that the concept is going to be the same. You're just going to have different numbers. Okay, so let me pull his up here real quick. Austin, scores, responses. And let's go to number 12. Okay, so let me change my paper here to some fresh paper. And I know you can't see you can see what's under my camera, but this may not come into the camera very quickly. So I'm just writing down the problem, and then I'll fix the paper and show you. Okay, so you were asked to find the magnitude of 2/3. Now you got that one right, Austin. So Okay, so let me fix the paper. You're asked to find the magnitude of negative 2/3 times u. You got it right. Yes, you always need to use absolute value, and here's why. The magnitude of a vector is the length of the vector. Length cannot be negative. So as you see in here, when you do the magnitude, right, you're going to take the square root, and you always have to use the positive square root because you're dealing with length. So in this case, there's a little rule that says, if you have the magnitude of a scalar or a number times a vector, then what you can do is pull that number, that constant multiple out, the absolute value of it, to make sure that it stays positive because it's representing length, and then multiply that to the magnitude of the vector itself. Does that make sense? Yeah, Donovan, right. So you've got to make sure, you got to remember that magnitude means length, and you can't have a negative length. Super important. So just take the absolute value. I mean, if it's positive, you don't have to write the absolute value symbol in, because the absolute value of any number, whether it's positive or negative, is going to yield a positive value. So just keep that in mind. If I said to you, I want you to find the magnitude of, negative 2 times vector u, well, that would be 2 times the components of, 2 times the component, the magnitude of the components, right? So again, you notice I just pulled the negative 2 out as a positive 2. All right, so just make that number positive. It's pretty much all you have to do. Any other pressing questions from the homework? Okay, well, once again, because some of you are just coming in now, if you do have a question on the homework, please do not send me messages through WebAssign. They have to come through Remind or Edsby. Okay, those are the only two venues I'm using. And because I have, I have kind of a state-of-the-art setup here with cameras and programs and things like that, I can actually record the screen and the webcam. So what you see under here at the same exact time, you have like a split window. So what I did for a student this morning was I actually did that, and I went into his homework submissions in WebAssign so he could see what he had responded to on the screen. And I had, in the corner of the screen that you see, I had the paper under the document camera, and I was actually solving the problems while we were addressing what was on, the problem that was on the screen. So I think I'm going to make number 10. Okay. So let's see. Avatar network is who again? Who again? Who again? I'm scrolling through. Loops. Yeah. Okay. So loops. Let me go into yours real quick. And loops, you're also in block 1. So let me go to scores and let me see your response for number 10. And again, I'm going to write this down. Okay, so in number 10, you wanted to find u plus v, u minus v, and 5u minus 4v. And vector u had components negative 3, 1, and vector v has components 0, 0. So let me come back to my live stream, okay? So we had to find all 3 of these things in number 10. So if I want to do u plus v, well, that's just the components of vector u plus the components of vector v. And all I'm doing is adding this component to this component. And so, if you want to think of this as x, y, x, y, I'm adding the x's together and the y's together. So the sum is just negative 3 plus 0, which is negative 3. And then for that y component, it's 1 plus 0, which would be 1. So that would be u plus v. If I want to do u minus v, you want to be careful here. If you're not really good with signed numbers, and some of you think you are and you're not, and I'm not bashing you, I'm just saying you need to be really careful. If you are definitely truly really good with them, then you don't have to go about this the baby way that I'm going to show you. There's nothing wrong with the baby way if it helps you to learn what it is you need to learn. All right. So what I showed you is you can write this as u plus the opposite of v. Okay. So what I've got is u plus, now the opposite of v means that I'm just going to change the signs. Well, 0 doesn't have a sign, so I can still think of it as 0, 0. Okay, and what's going to happen is if this is u plus the opposite of v, then all I'm doing is changing the signs here. In this case, 0, 0, it's not going to work. So you're going to get the same answer, -3, 1. But just for a second, let's just suppose that v was 1, 1, okay? And I wanted to do u minus v. Well, that would be -3, 1 minus 1, 1, right? But rather than think of it this way, do it like this. Write your first vector down the way it was, change the minus to plus, and just change every sign inside the components for the second vector. And so now, when you add, remember, if the numbers have the same sign when you add and you keep the same sign. Well, the 3 and the 1 are both negative, so I'm going to add to get a 4, and I'm going to keep the same sign. Okay, comma. Now here the signs are different, right? 1 and -1. And the rule is when the signs are different, you subtract the numbers and you use the sign of the bigger number. Well, 1 plus a -1 gives us a 0. So there is no sign to 0. Does that make sense, Lubes? Hello, Lubes? You good with that? Okay, so I'm just going to continue on then until I hear back from him. Well, Jaden, you're good with it, but Lubes is the one who asked the question, so I just want to make sure he's okay with it. But thanks for responding, Jaden. I'm going to carry on, but remember, if you have any question where you need help, please send it to me through Edsby or through Remind. Now, Remind is ideal because I get the message instantly. It's a flawless platform. My phone dings, so it's like, oh, hey, I got a message, and then I can address it real quick. And then I can make, a 2-minute video working this thing out, and I can send it to you. Okay, so let's get started with the lesson. And in order to get started with the lesson, we need to review a few things way back from chapter 2. So that was a long time ago, okay? Because some of these things you may have forgotten. So in chapter 2, section 4, we learned about imaginary numbers, all right, or complex numbers. Complex numbers is just a number that contains an imaginary unit, okay? And the imaginary unit is called I. And this is very, very important right here that you remember that I is equal to the square root of -1, and that if I square both sides, I get I squared is equal to -1. Those you must know, okay? So what we have is this complex number which takes on the form a plus bi, okay? A is the real part, b is the imaginary part, and the whole thing together is called a complex number in standard form. And when we get to the section that I'm supposed to be working in, section 6.5, you're going to see it written as z equals, okay? So we usually denote a complex number by z. Z equals the complex number a plus bi. Okay? It's the same thing. It's just this one doesn't have the z, okay? But they're equal. And remember that if you want to add two complex numbers, you're going to add the real parts, and then you're going to add the imaginary parts, and you're going to write that complex number in the form a plus bi, or in standard form, always, okay? So I have an example here. Let's add these two complex numbers. Well, this is the real part of this first one, and this is the real part of the second, so 7 plus 2 is 9. And then I've got the imaginary parts that I have to add, 3i plus 4i. The signs are the same, so I add and I keep the same sign, and we get 7i. So this would be the sum of the two complex numbers in standard form. All right, always write your answer in standard form. And the reason I'm stressing that is because if you take a district exam, you're going to see it in standard form. Also, in WebAssign, you may have to write it in that standard form, right? You have to kind of keep with a certain format. So just keep that in mind. All right. If you want to subtract, you do the same thing. Okay. You can change any subtraction problem to an addition problem. So for an example, if I have 4 plus 2i minus the quantity 6 or the complex number 6 plus I can change this to addition, provided that I change the signs of the terms inside. So you notice I changed this to a plus, the positive 6 became negative, the positive I became negative. Okay, so you just, if this were a negative 6 plus I, the 6 would become positive and the I would become negative. So you just change the signs of whatever is in there. Now I can add, right? 4 plus a negative 6, the signs are different. We subtract and use the sign of the bigger number. 6 is bigger than 4. It's the bigger number. It's negative. So 6 minus 4 is 2, and I keep the negative. 2i plus a negative I is just, 2i minus I. Well, it's just like adding 2x or minus x. Or you can think of it like this, right? The signs are different. We subtract. We use the sign of the bigger number. So the answer to that is negative 2 plus I in standard form. Is everybody okay with that? Do you remember that? My goodness. Background noise. Is everybody okay with that? Just type a Y for yes or an N for no real quick. Okay. Here's another example. Here, I want to subtract these two complex numbers. Notice what I did. I changed subtraction to a plus. And, again, if you're good with this, you don't have to do this. But if you're not, or you make mistakes or you get problems wrong, then to be extra careful, you could do this method, all right? I'm changing negative to positive, and I'm changing the signs of everything inside. So this was a positive 5, so it becomes negative. This was a negative 3i, it becomes positive. And now I'm going to add the real parts and the imaginary parts. So 3 plus a negative 5 gives you a negative 2. The signs are different. We subtract. 5 minus 3 is 2, and we keep the sign of the bigger number. 5 is bigger than 3. It's negative, so I'm going to keep that sign there. Then I have 4i plus 3i gives me 7i. So this right here is the sum or the difference of those two complex numbers. Now, when we multiply complex numbers, if I'm multiplying by a scalar or a number, that's real easy because it's just sort of like the distributive property, right? I do 4 times negative 2 and I get negative 8. And then I multiply the 4 to the imaginary part. 4 times 3i gives me 12i. Piece of cake. But here, now we're going to have to FOIL, and we're going to have to be careful. Because not only are we foiling, but we have to remember the fact that I squared is equal to negative 1. So let me FOIL that out to the side here. Remember, first, outer, inner, last, right? So I'm going to do 2 times 1 is 2. 2 times a positive 2i is a positive 4i. 3i times 1 is a positive 3i. And 3i times 2i is going to give me a positive 6i squared. Okay, so this is the piece where you got to be really careful. And remember that, hey, I'm going to have to substitute that I squared with a negative 1. Okay, so I'm going to do that. I'm going to rewrite this or clean it up a little bit as 2. Now these are like terms, so 4i plus 3i is 7i. And over here, what I have is plus 6 times negative 1. So I'm replacing the I squared. Remember, that equals negative 1. And now I can clean this up a little bit more. I have 2 plus 7i minus 6. And now I can combine the real parts together. So 2 plus a negative 6 is a negative 4 plus 7i. So the product of these two complex numbers yields this complex number right here. Are we still doing okay? I'll take a sip of coffee while I wait. Few more things. Conjugates. Equally important because when we work in the complex plane, you're going to have to plot them. Okay? So remember that a conjugate is just the opposite, okay, of, well, not the complete opposite, but the opposite of what's given. So the conjugate of a plus bi is a minus bi. The only thing you change with a conjugate is the sign in the middle, okay? The conjugate of a minus bi is a plus bi. Again, the only thing that's changing is the sign in the middle. All right, so the first thing, the first example you might see on your homework is multiply 1 plus I to its or by its conjugate. Well, they're not going to tell you what the conjugate is, okay? You have to know that if I'm given 1 plus I and I'm told to multiply it by the conjugate, then the conjugate is 1 minus I. Well, if I multiply those two, I'm going to have to FOIL again, right? Which is really the distributive property. And you know I hate the word FOIL, but hey, whatever works for you guys. So we've got 1 times 1 is 1. 1 times negative I is negative I times 1 is a positive 1i. And I times negative I is negative I squared. Now the beautiful thing about conjugates is that the middle terms are going to be opposite in sign and they're going to have the same coefficient. So they're going to cancel. So you don't even need to do all the FOILing work. All you have to remember is to multiply the first two and then multiply the last two. Those are the only two I need to multiply to get my complex number. So what I have here is 1 minus I squared. But remember that I squared is equal to a negative 1. So you've got to be very careful when you plug that negative 1 in. And 1 minus a minus 1 becomes 1 plus 1 or 2. Now, how do I write that in standard form? Well, this would be 2 plus 0 times I, because 0 times anything is 0, and we don't write the 0. Because 6.4 is not part of the curriculum anymore, or at least up to this point it's not. Maybe it'll come in later on somewhere down the road. It's been an interesting curricular ride through this course since they've changed it. So the powers that be decided you don't need it. So that's why. Okay, so the answer is just 2 plus 0i or 2. Yes, you do need to know I and I squared. So I is equal to the square root of negative 1, and I squared is equal to negative 1. That's if I square both sides. Okay, you must know those. You need to know those two facts. You need to know how to add and subtract complex numbers. You need to know how to multiply complex numbers either by a number or by another complex number like what I'm doing right now. You need to know what the conjugate of a complex number is. All of those things you need to know, and you'll see why in a little bit. No. So, okay. You have I squared, I cubed, and whatnot, and those are kind of cool because after the fourth one, they start repeating themselves as far as the values are concerned. And you don't necessarily need to know that. You should if you want to go into higher math, but you don't have to know it. Okay, so the next example says multiply 2 minus 5i by its conjugate. So I have 2 minus 5i. That means I'm going to multiply it by 2 plus 5i. And remember, those middle terms are going to cancel out. Art involves a lot of mathematics. It involves a lot of mathematics. Just saying. Look at M.C. Escher's work. Okay, so we're going to multiply, right? But since they're conjugates, I don't have to FOIL this whole thing out and then cancel stuff in the middle. I know that if I multiply the first two terms, 2 times 2 is 4, and then I multiply the last two terms, so the last term of this binomial and the last term of that binomial, I get negative 25i. Now I'm going to do it out real quick just so you can see, right? We got 2 times 2 is 4. 2 times positive 5i is a positive 10i. Negative 5i times 2 is a negative 10i. And negative 5i times positive 5i is negative 25i squared. And I forgot my square there. And you see those cancel out. So rather than doing all of the work of FOILing, all I need to do is multiply the first two together and add or subtract it from the second two. That's going to happen naturally depending on this sign. And then I have to use the property that I squared is negative 1. And a negative times a negative is going to make that a positive. So we have 4 plus 25 or 29. Capiche? So that was the little review of Chapter 2, Section 4. Okay, just refreshing your memories about some properties of complex numbers. So now let's go into the complex plane. So this is Section 6.5, not 3, 5, and it begins on page 438 of your book, so you know where to look. I made a note here that on the side, so I'm going to start here. I know it seems a little haphazard, but remember that I can write z equals to 0 plus bi if the real part, so you might see something like z is equal to 3i. That means that the real part is 0, okay? So we don't write it out as 0 plus 3i, we just write it as 3i, but I'm letting you know that that means the real part is 0. Likewise, I might have something like z equals to 3. Well, that means the imaginary part is multiplied by 0. So again, we don't write that out that way. We would just say, z is equal to 3, but we need to know that the imaginary part is 0. Why do we need to know that? Because we're going to be plotting complex numbers on the plane, okay? Now, a complex number, again, is of the form a plus bi. A little more sophistication, you can think of it as x plus yi. And not only is this more sophisticated, but it would help you more because we have an x direction and a y direction in the plane, okay? So, you're going to plot these complex numbers according to x, y direction, so to speak. However, you notice I have r and I here. So in the x direction, that's the real direction, and the y direction is the imaginary direction. Now, I didn't put any little tick marks on here like I should have, because I wrote these notes very quickly. Okay, so I'm going to plot these points here. The first one is plot 2 plus I. Okay, well, remember, these complex numbers are just going to be points in the plane. So all I have to do is move over. You always start at the origin. I have to move over 2 in the x direction and 1 in the y direction or I direction, okay? So I go over 2 and up 1, and I plot it, and I'll call that green and green. If I want to plot the second complex number, which I will denote as an orange number, then I need to plot the point -1, -2. -1 in the real direction and -2 in the imaginary direction. Now again, if I'm going in the negative x direction, I'm going to the left of the origin, and the negative y or I direction is below the x-axis, right? So I'm just going to go over to -1, -2, and plot a point, and that's z sup, meaning superscript orange. If I want to plot the third one, I'm going to go over 3, up 2, and I'm going to plot this complex number here. And again, the reason why I brought this up first is because you may be asked to plot something like negative I. Well, there's no real part there. Where do I go? Well, that means that the real part is 0. So you can think of this, so I'll call this brown, 0 minus I. So that means I start at the origin and I just go down 1 unit. Is that okay? So these points can end up all over the plane, and they're real easy to plot. Just think of the real part as x and the coefficient of I, the imaginary part, as y, and it's just as easy as plotting any point. Now guess what? Complex numbers have a moduli or a modulus, which is really just a fancy word meaning the absolute value. But it's super easy because the modulus of a complex number, or the absolute value of a complex number, is just the square root of the real part squared plus the imaginary part squared. Now, it's the coefficient of the imaginary part. You notice I have b and not bi in here, all right? So, for instance, if z is negative 2 plus 5i, and I need to find the modulus of z, of that complex number, then all I have to do is take the real part and square it, and then add that to the coefficient. I want to say that because I don't want you guys plugging i's in there. Plus 5 squared. And negative 2 squared gives us a 4, and 5 squared gives us a 25, and so that gives us the square root of 29, and we cannot simplify it. So that's pretty easy stuff. Do you all agree? I'll take a sip of coffee while I'm waiting. All right. Addition, subtraction. Guess what? It's the same as adding or subtracting two vectors. Isn't that something? What you do is, so let me go back up here. Let's look at this blue complex number right here. Couldn't I take a line and connect it from the origin and stop at that point? I could. Or the orange vector, I could start at the origin and draw a line and stop at that point. Yep, right? I could do one, I don't even know what color, brown, I guess. It's gonna be hard to see, but I could start at the origin and go to this little point here. So guess what? Adding or subtracting complex numbers is the same as adding or subtracting the components of a vector. So let's go back down here and see how this works. Okay, so what you do is this. You're given a complex number, which is of the form a plus bi, and you call it some vector. I'm calling it vector u, okay? Well, I'm going to throw the components in there. The components of this would be a comma b, right? And if I have some other complex number, c plus di, and I just use c and d to let you know that this is a different number than this one, I'm going to call it vector v, and it's going to have components c comma d. So did you know that if I wanted to add those components, I'm going to do it just like I do with a vector. I'm going to add a plus c comma b plus d. And if I want to subtract, again, I can, if I'm really good using signs, I can just do, a minus c comma b minus d. So distributing the sign in, so to speak. But if you want to change it to an addition problem and then change the signs, that's fine too. Whatever is easiest for you, as long as you're getting the answer right, I don't care how you do it, okay? And so we get the final sum or difference as a component vector. So here is an example. Z sub 1, the complex number, Z sub 1 is 2 plus 3i, and Z sub 2 is the complex number of 1 plus 2i. They want you to find the sum of those two complex numbers and the difference. So that's why you see this little plus minus here. Okay? So I'm going to call this complex number vector u, which has components 2, 3. And I'm going to call this complex number vector v. And remember, I said I forget my little arrows. With components 1, 2. Well, if I want to add u plus v, that's 2 plus 1 gives me 3, and 3 plus 2 gives me 5. And if I want to plot that sum on the plane, I just go over 3 up 5, plot a point, and connect it with a directed line segment. Are we all okay with that? Okay. Now suppose I want to do u minus v. Well, that's 2 minus 1 is 1, and 3 minus 2 is 1. And if I needed to, so that's the component form, right, of my new complex number, or my vector. And if I want to graph it in the plane, or if I have to, because that's part of my web assign homework, well, then I'm going to go over 1, 1 and plot a point and connect it with a directed line segment. It's cool stuff. And vectors are everywhere, and the higher you go up in mathematics, the more we use vectors. Vectors just makes the world clear. They're really important. Okay, so far what we've done, and if there are any questions, please don't hesitate to ask. So far what we did was we looked at complex numbers, right? Their general form or their standard form. We could plot some complex numbers. We could find the modulus of a complex number. And then we can kind of convert those complex numbers into position vectors and write them with as a component, right? Components for those vectors, and add or subtract very easily. Here's another one. It says add the two complex numbers and then graph. So again, I have two completely different complex numbers. I'm going to call this one u and write its components. And I'm going to call the purple one v and write it in component form. I'm going to add my vectors. So there are no, they're all positive numbers, so real easy to add them together. So when I add the components of those two vectors, I get the new vector 3, 4. I can rewrite that real easily as a complex number, 3 plus 4i, and then I can graph it. I can start at the origin, go over 3, up 4, plot the point. There's my complex number in the plane, and if I connect it with a directed line segment, I've got my graph. Una más, una más, una más. I have two more complex numbers here. So I'm going to rewrite this one as vector u in component form. I'm going to write this one as vector v in component form. Okay, I'm asked to add and graph. So again, 3 plus 1 is 4, and 1 plus 2 is 3. That gives me the component vector 4, 3. But if I want to or need to rewrite it as a complex number, I can just write it as 4 plus 3i in standard form. On my graph, I start at the origin. I go over 4 units, up 3 units, plot the point, and connect it with a directed line segment, and I've got the vector u plus v. Now subtraction, I'm going to do a couple of those. Remember, if you have to, change the sign. All right, but you are going to have to subtract in the complex plane and more than likely plot the result. So we want to find the difference of those two complex numbers. So what I did again, and you don't have to do this, is I changed subtraction to addition, and I just changed the signs inside of there. So this complex number converts to the components of, we can call this vector u if we want to. I'll call it vector u. And this complex number we can convert to the components of vector v. Right? And if I want to add vector components, I just add their corresponding components. So 4 plus a negative 3 gives me a positive 1, and 2 plus a positive 1 gives me 3. I can reconvert that result into a complex number, start at the origin, go over 1, up 3, plot the point, and connect it with a directed line segment. So I can say that this is u minus v, or u plus the opposite of v. Oops, sorry. Or u plus the opposite of v. Let's look at the conjugates now. In upper level math, we denote the conjugate of a complex number with a star. Okay, so if I'm given a complex number z, and I need to write down its conjugate or plot its conjugate or whatever, we call the conjugate z star. And again, we're just changing that middle sign, right? So, example, you want to plot z equals negative 3 plus I and its complex conjugate in the plane. Well, we know how to do that, right? We know how to plot these complex numbers. First, I'm going to start at the origin, and I'm going to go over 3 to the left and up 1, right? So I start at the origin, I went over 3 to the left and up 1, and I plotted z. Now I'm going to plot the complex conjugate. So, you know, I may want to write down what the complex conjugate is. And I want you to notice, because I did write it down, I didn't change the signs of A at all. They're the same. What I did change was the sign in the middle, right? I changed, this was the positive, that's what they gave me, and I changed that to a negative. So it's only the sign in the middle that you change. So if I want to plot z star, well, that means I'm going to start at the origin, I'm going to go over 3 to the left, but down 1. So they're kind of a reflection over the x-axis here. Okay. In my next example, it says plot negative I and its conjugate. Well, I know how to plot negative I, or negative 1. That means that z is equal to 0 minus I. So that means the conjugate must be 0 plus I, right? If I want to plot z, I start at the origin and I go down 1. So I already did that and plotted the point. So this is z here. And if I want to plot the complex conjugate, I start at 0 and I go up 1, and I call this one z star. It's pretty easy stuff. And that's it for your lesson today. Not too bad in 42 minutes and 51 seconds. So are there any questions about section 2.4 or about section 6.5? Any questions at all before I end the stream? If you don't have any questions, feel free to get off the chat, exit out of YouTube, and you can start working on your homework, which is in WebAssign. It was good to see all of you. I wish I could see you in person, but anyway, that'll be a while, if at all. Is the graph above for 0 minus I? And yeah, okay. So the first example for this complex number and its conjugate were these two, right? I used the same grid. So yes, I used the same plane to plot negative I and positive I, and I plotted them right there. Does that help? The homework is always due by the start of the next class. So it'll be open until 9 a.m. I think it's 9 a.m. or 10 a.m. on Friday. So just like when we were seeing each other in person, right? I would give you homework, you'd work on some in class, what you didn't finish, you would take home and finish, and then it was to be ready to go by the next time I saw you or the next class. So it'll always be like that. Cengage is due by Friday. WebAssign, they're the same thing, in case you don't know. We'll redo the homework multiple times if we miss some questions. I believe, is WebAssign not allowing you to do a second try, or? So in other words, if you answer something and it's wrong, can you try another problem of the same type again, or is that it? It is what? Yeah, I thought I put 5 tries, which is pretty generous. I think you can have up to 5 attempts to get it right. And out of those 5, since well, I don't know, I shouldn't say you have, because it's not multiple choice necessarily. Okay, so yeah, I'm giving you attempts. Now, if I give you a quiz or a test on WebAssign, you'd only get 1 try. All right, so check the number of tries. Can somebody direct us, since you can't see my computer screen because I'm only in webcam mode? Let me just check here. Can somebody direct us on where you can see in your WebAssign where it says you have 5 tries? No, that's good. You don't have to use them all, but they're there if you do need them. So what I'm trying to do is encourage you that if you got it wrong, don't fret, try it again. So while you're working on the same problem, maybe you need to be careful with your signs using the distance formula, or maybe you jotted down the wrong number for an X or a Y or something like that. So I want to give you the opportunity to learn from your mistakes. So I don't mind if it takes you 5 times to get it right, as long as you get it right. That's what I care about. And I also care that it's done by the due date. Because I don't like to give zeros and F's and all that, but I have an obligation to as a teacher. Yeah, you got the formulas mixed up. So, right, you could accidentally mix up the formulas. You could subtract x from y instead of x from x. There's a whole bunch of, variables involved on why you could get something wrong. But again, you get all of those tries to try and alleviate it. And if you tried 5 times and you're still getting the wrong answer, then what you need to do is go to EDSB or Remind and say, Ms. Wilson, I keep trying this problem and I keep getting it wrong. Can you help me? And of course, as you know, I will. Anything else? Are we all good? Are we all good? No, you're not good, Boobs? Oh, okay. So you guys were talking to each other. Didn't I say there was no talking in class? I'm kidding. All right. So I'm going to sign out of here because I've got some video solutions to create for a couple of kids. And again, go to WebAssign, work the rest of your 90 minutes on your homework. If you have any questions, please don't hesitate to let me know. Check for my office hours, which is posted in your ESB account. Because if you come to me as pre-calc when I'm in BC office hours, for example, I'm probably not going to see your question until much later. I will get to it, so I don't mind answering a question after office hours, but when I'm in office hours for a particular class, it's for that class only. So I just wanted to clarify that for you. All right, have a great day, you guys. See you later.